Good morning, grade sixes. Welcome to your daily lesson of mathematics brought to you by WorksheetCloud. I hope you guys are all really well and looking forward to today's lesson. A reminder of the email address on your screen. Please use it as you like. Send me some feedback and some questions or maybe some ideas of work that you'd like covered moving forward, and I'll be more than happy to do so for you. Today we are looking at analyzing data. So our main theme is going to be looking at two types of averages. That's the mean and the range. But before we get into that, we'll have our warm-ups, our mental maths questions covering previously taught topics, and then to finish off we've got our brain benders and challenges. So here is your warm-up activity today, a bit of a superhero theme. So Spider-Man, Wonder Woman, Groot, Thor, Hulk, tell me the value of all those characters, and then don't forget to tell me the value of the question mark at the end. Guys, make sure that you write down your thoughts on a piece of paper. Just remember, we've spoken a lot about how writing down can make things more understandable for us. And yeah, give it your best shot, and let's see how you guys get on. There are a number of places we can start here. I first started on the fourth line, and I recognize that 3 is equal to 21 divided by 7. Okay, so Wonder Woman is 7. I also recognize that Hulk and Thor were equal, which means 33 is equal to 11 add 11 add 11. Okay, I know that Groot and Spider-Man are equal, so if I go to the top line, and I know Wonder Woman is 7, 31 minus 7 is 24. That means Spider-Man is 12 and Groot is 12. Okay, so 12 add 7 add 12 gives me 31. So let's just fill in that these two guys are 12 and these two guys are 11. Okay, and then we need to look at the order of operations in our final part of the puzzle. So Hulk we know is 11, Groot we know is 12. Then we need to divide by 11 and multiply by Spider-Man, which is 12. Okay? Now, division needs to come first. Okay? And what I'm actually going to do here is I'm going to write this in fraction form. And if you just give me a second, we know that 12 divided by 11 can be written as 12 over 11. And we know we can multiply by 12 over 1. Okay? Now when we multiply fractions, we can cross cancel, okay, which means if 11 goes into 11, we can cancel them out, and that leaves us with 1 and 1. And now all we have left at the top is 12 multiplied by 12, which equals 144. And you can see at the bottom that it's 1 times 1 times 1. And that's going to give us an answer, obviously, of 1. And we know that anything over 1 is equal to the numerator itself. So our final answer is 144. So I've challenged you there a little bit. I've gone beyond the grade 6 fraction curriculum just to see if you guys are capable of following. Multiplication of fractions like that sometimes only gets taught in grade 7. So depending on what you've been taught in fractions will more than likely depend on whether you knew that final step. But go back and have a look. Just to recap, on previous lessons on fractions, we did quite a big series on that. And hopefully that will help you understand the work that I've just done on the screen for you. Okay, let's move on to our mental arithmetic questions for today. There's 7 of them. Please work through them slowly, methodically, write down all your thoughts, work logically and neatly, and yeah, let's see how you guys get on. As your mental arithmetic practice, so first question, 381,06, and to that we are adding 269,16, and let's remember to put all the numbers in the correct columns, and then we add normally. 6 add 6 is 12. We need to carry the 10. 1 add 1 is 2. And just remember, it's actually not 1 and 1, it's actually 1/10, and 1/10 is 2/10. 1 and 9 is 10, you need to carry that 1 again. 8 and 6 is 14, plus the 1 is 15, and then 3 and 2 is 5, plus that 1 is 6. Your second question, subtraction, can sometimes be a little bit more tricky. And let's subtract 2,949. Okay, and now we've got all the numbers in the correct columns. The decimals line up. We can simply subtract as per usual and borrow when we need to. And you will see that you should get an answer of 2,732. And yes, I heard you say it. You need to check, and let's do it. Let's do the opposite of subtract, which is add. 2 plus 9 is 11. Absolutely. 4 and 3 is 7. Yes. 7 and 9 is 16. Yep. And 2 and 2 is 4. And that must tell us that our calculation is correct. Your next question, question 3, is multiplication. And we've spoken quite often about the numerous ways that you can do a multiplication sum. Okay, so we have 95 times 37. Okay, we can't double and halve because they're both odd. We can do a split strategy. What I'm actually going to do here is I'm going to do a compensation strategy. So I'm actually going to say 100 multiplied by 37, and we know that's 3,700. Okay, and then I need to figure out what's 5 times 37. Okay, and I know 30 times 5 is 150. 7 times 5 is 35. So 150 plus 35 is 185. And then I clearly need to take off 185 from 3,700. Okay, and if we go back 100, that's going to be 3,600. And if we go back 85 from that, that's going to give us 3,515. Okay, so that's the compensation method, which we actually haven't spoken about for a while. But let's go see if that calculation was indeed correct, or if I made any errors. And we can just maybe have a look at your traditional column method. Okay, and 7 times 5 is 35. 7 times 9 is 63. So add the 3 is 66. And then the all-important placeholder. 3 times 5 is 15. Carry the 1. 3 times 9 is 27. Plus that 1 is 28. And then if I add, let's create some space quickly. 5 and 0 is 5. Okay, so that number's correct. 6 and 5 is 11. Okay, so my 1 is correct. 6 and 8 is 14, plus 1 is 15, so my 5 must be correct. And then I need to carry the 1, and 1 and 2 is 3, so I know I must be correct. So there are a couple of methods there for you guys to try out. Question number 4 is short division. Okay, and we can do short division using this method, which has multiple names. But ultimately it's the short division method. Okay, and let's just recap quickly. How do we know if 891 is going to be divisible by 3 and give me a whole number as an answer? So is 891 divisible by 3? Remember, we need to add up the individual digits in 891. So 8 plus 9 plus 1, that's going to give me 18. Is 18 divisible by 3? Yes, it is. So therefore, we know that 891 is going to be divisible by 3 perfectly. Okay, so that was just a little recap on a divisibility rule of 3. Really, really handy for you guys to remember that moving forward. 3 goes into 8 twice, leaves you with 2. 3 goes into 29 9 times. 9 times 3 is 27. So that leaves you with 2. And then 3 goes into 21 7 times. And then remember to check, we do the inverse, 297 times 3. So if I say 200 times 3, 600. 90 times 3 is 270. And then 3 times 3 is 21. And if I add all of those together, you can see I'm going to get 891, which is what the number that I started with. So we must know that our division calculation is indeed correct. Okay, question number 5 is the addition of fractions. And again, you can notice that the denominators are different. So 3/10 plus 1/3. I need to find the lowest common multiple of 10 and 3, which would give me the lowest common denominator of 30. And 10 goes into 30 3 times, so 3 times 3 is 9. 3 goes into 30 10 times, 10 times 1 is 10. And then I add them together, I get 19 over 30. And that's the simplest form of that fraction. So we're all good there. Multiplying by 10, I'm pretty certain and confident that you guys understand that when I multiply by 10, my number gets one place bigger. So 167 multiplied by 10, we just need to add that 0 on the end and we get 1,670. And then your last question, you need to know that brackets comes first. Okay, so 5 plus 2 is 7, and 7 times 5 is equal to 35. Okay guys, I hope you guys work through those nice and carefully. If you've made any errors, please make sure you understand those errors. If you still don't understand, then please send me an email and I'll be more than happy to explain it further during one of our next lessons. Okay, so the main theme for today was data handling, and we were looking at two different types of averages. So the first average we're going to be looking at is called the mean, and the mean is actually your traditional average, and it's the most commonly used average. It's not often called the mean, it's simply just called the average. So to calculate the mean or the average, we add together the values in the sets in the data set and we divide by the total number of values. So that gives us the formula on your screen. The mean equals the sum of the values over the number of values. So an example of that is, how would you calculate the mean of 3, 6, 7, 9, and 9? So the first thing you need to do is you need to add up all those numbers. So 3 at 6 at 7 at 9 and 9, and that would give you 34. And then you need to divide by 5. Now the reason it's 5 is because there are 5 entries. So if you add, or if you have a look, 3, 6, 7, 9, and 9, that's 5 entries, and that's what we mean by the number of values. So your answer there is going to be 6,8. Okay, so that's the way you work out the mean, which is more commonly known as the average, but it is actually a type of average. Okay, so here's a problem involving the mean. So if a pupil, so let's say yourself, if you scored 78%, 75%, and 82% in 3 tests, what must you score in the 4th test to get an overall mean of 80%? Okay, so it's a little bit of a different way to ask a problem involving averages. So for you to get a mean of 80%, the 4 marks must add up to 320, because 320 divided by 4 is equal to 80%. All right, so we know that the first 3 marks, the 78, the 75, and the 82, if you add them up, you're going to get 235. So what do I need to add to 235 to get to 320? And we can work that out through a subtraction method, and that's going to give us 85%. So if you wanted to check, you could say, or work out 78 plus 75 plus 82 plus 85. That would give you 320, and then we need to divide the 320 by 4 because there are 4 test results, and that would give you an average or a mean of 80%. We can also calculate the mean from a frequency table, and a frequency table is just a table such as the one on your screen, which shows us the number of occasions a particular score happens. So the way we read this frequency table is that the score 1 was achieved 8 times. The score 2 was achieved 11 times. The score 3 was achieved 6 times. The score 4 was achieved 9 times. The score 5 was achieved 9 times. And the score 6 was achieved 7 times. So as you can see in the description of the frequency table, the dice was thrown 50 times. Okay, so if you added up the frequencies 8, 11, 6, 9, 9 and 7, you should get an answer of 50. All right, and now we want to know what is the mean score. So we need to figure out the score multiplied by the frequency. Okay, so if we throw the number 1 8 times, then we know that that answer is going to be 8, because 8 times 1 is 8. If we throw the number 2 11 times, 11 times 2 is 22, 6 times 3 is 18, 9 times 4 is 36, 9 times 5 is 45, and 7 times 6 is 42. So that's going to give you the individual totals for each score. Then what we need to do is we need to add them up. And as I said in the beginning, your frequencies should add up to 50 because we rolled the dice 50 times. And the total after rolling the dice 50 times gives us a score of 171. So now we know the total score of 171. We know the number of times we rolled the dice is 50. To work out the mean, we need to divide 171 by 50, and that's going to give us an answer of 3,42. So the mean from rolling the dice 50 times is 3,42. I know that you cannot get an answer of 3,42 when you roll a dice, so sometimes they might ask you to round off that answer to the nearest whole number, and if they did, then you would round 3,42 off to 3. Okay? But 3,42 is your average of the dice thrown 50 times. The next type of range or data handling measure that we'd like to talk about is range. And the range of a set of data is a measure of how the data is spread across a distribution. So what do we mean by that is to find the range, we subtract the lowest value in the set from the highest value in the set, and that gives us an idea of how much the data spreads across, and that's the range. Okay, so what does it mean if the range is small? So when the range is small, it tells us the values are very similar in size. Okay, so for example, if you had to calculate the range of the finishing times in the 100-meter sprint in the Olympic Games, those times are all really, really close to each other, quite often less than half a second apart. So your spread of data for that particular piece of information is going to be really, really low, okay, because all the times are close together. What does it mean if the range is large? You're quite right. If the range is large, it tells us that the values vary widely in size, and large ranges could be anything from the distance a golf ball is hit by various numbers of people. I can't hit a golf ball very far, but you might be able to hit the golf ball a few hundred yards. And then to figure out the range, my distance on playing golf is probably going to be less than 100 meters. One of you might be a few hundred, and then you can see the range is going to be quite large. So it's just useful knowing why ranges are big and why they are small. And just remember that to work out the range, you need the highest value minus the lowest value. Okay? So I'll just put these on the screen for you to consult with moving forward. We still need to cover median. But yeah, you know, the mode. So your mode is going to be the value that occurs most often. The median is the middle value of a set of data, but don't panic about those. We'll get into them. Your mean, as we've just discussed, you can see that it says add and then divide. All right, so there's a nice visual for you to remember how to work out the mean. First add and then divide, and then your range. is your largest value minus your smallest value. And I just thought those might be handy for you to remember moving forward. So the three types of averages we can have a look at. And we know that mean is the sum of values over the number of values. Median is the middle value. And the mode is the most common value. The range is not exactly an average, but it still tells you how the data is spread out. So we still include it in the topic of averages, and it ties in quite nicely with data handling. And there's just a recap of how to work out the range. Okay, so each type of average has its purpose, and sometimes one is more preferable to the other. So the mode is easy to find, and it eliminates some of the effects of extreme values. So just remember that your mode is your most common value in a set of data. We've spoken about the modes. You can have two modes, you can have more than two modes, and a set of data can also have no modes if there's no repeated entry. Okay, it's used for categorical or non-numerical data, and we've covered that in a previous lesson. If you don't remember the mode, then I encourage you to go back and have a look at that lesson so that you can brush up on that information and remember it moving forward. The median was also covered in a previous lesson, so this is just a recap for you. And the median is an easy way to find the average. And when we talk about rogue values, we talk about outliers. So if I have a set of data 1, 2, 3, 4, and then all of a sudden there's a value of 100, 100's so far away from the other entries of 1, 2, 3, 4 that it's called a rogue value. Now, if you had to try and work out the median using that rogue value, it often doesn't affect the total result, and the median is the best average to use when there is a rogue value. We've spoken about the mean in this lesson, and it is the most difficult to calculate because you have to add and then divide, but it also gives you a really accurate average and idea of what the data is representing. If there was a rogue value, then you could still work out the mean, but the median would be a better average to use if there was a rogue value, where the rogue value would clearly affect the mean of a set of data. So let's have a go, or I'm just going to give you guys a turn to work through these 5 questions that pertain to the table on the right hand side. Read the questions carefully, go back and refer to the information we've just talked through on the previous slides, and then press play and see how you guys get on. Let's have a look at this question. The table on the right shows the amount of money raised by your class at a recent fundraiser. Question number 1 asks, what is the mean or average amount of money raised? So you can see I've already put in the total of the money raised, 1,330 Rand. And we know that to work out the mean, we need to divide 1,330 by 7. Okay, and we can do this in a short division method that we've spoken about before. And we know that 7 goes into 13 once with 6 left over, goes into 63 9 times, and it doesn't go into 0. So that answer is 190. So your average amount raised per week is 190 Rand. The median amount, so just to recap, a median, we need to put all the numbers down, but we need to put them in ascending order. So remember, ascending is smallest to biggest. So your smallest amount there is 90. Okay, your next amount there is 110, then 120, then 130, okay, 140, 150, and there's 590, which is a little bit of an outlier or a rogue value. Okay, and now we just need to find the middle number. So we can cross off the outside numbers okay, and it's an odd set of numbers, so the data set is odd, so your median is quite easy to find out as it's just the middle value, and that gives us a value of 130 Rand. So the third question is, which do you think better reflects the weekly figures and why? So do you think the mean is a better reflection of the weekly figures, which remember was 190 Rand? Or do you think the median is a better reflection? And I'm going to say the median is a better reflection purely because of the outlier of 590 Rand. Okay, so the 130 Rand is a closer value to most of the entries, whereas 190 Rand, which was the average, is a little bit further away from most of the entries. Okay, so just make sure that you recognize that there is a rogue value, which is 590, and also recognize how that 590 actually affects the overall mean of the set of data. Does this set of data have a mode? And if you have a look, are there any repeated values? No, there are not. So therefore, question 4's answer would be no, there's no mode because there's no repeated data entry. Okay, all the numbers are different. Your last question there is, what is the range? So we look for the highest value is 500, the lowest value is 90, and we know that 590 minus 90 is 500. So that is going to be the range of that set of data. Okay, guys, that leaves us onto our finisher of the game 24. And this is one of the last cards on this blue level. And I'm going to be looking to bump you up into the next level moving forward. So use each number on each card. So for example, on the first card, 2, 8, 7, and 4. Can you use those 4 numbers with add, subtract, multiply, or divide and get the answer of 24? You don't have to use all the operational signs. You can use one of them, 2 of them, or a combination of them, but you need to get the answer of 24 and see if there are different ways of getting to the answer of 24 using the same 4 numbers. Grade 6s, thanks so much for joining me today. I hope you guys consolidated some information or perhaps learned something new. Please have a look at the online activities with memos that you can use to consolidate the information I've just spoken to you about. And remember to send me any questions or queries or feedback on the email address grade6@worksheetcloud.com. I look forward to hearing from you. Have a really cool day. Keep safe. All the best.